Algebra 1, this is chapter 6.1. We're going to actually solve systems of linear equations by graphing. So this whole entire section is all about graphing, which is kind of nice, leads from what we just did in chapter 5 with the inequalities, but these are not shaded. You just have to look for where the lines are and where they cross. Okay, so what we're going to talk about here is the fact that lines, when you have more than one, they have a couple different options. And what we're going to do is, if you put two lines together, it forms what they call a system of equations. And you could have two lines that cross somewhere. You could have one that, basically two equations that are exactly the same. Or you could have two equations that are parallel and they never will meet up. So they have a couple different names for these things. And what they have is one solution, infinite amount of solutions, and no solutions. If it has one solution, it is considered consistent. A consistent, guys, has at least one solution or intersection point. So both one solution and infinite systems are both considered consistent. Now, if there's only one, and only one of you, then you are pretty independent. When you're out by yourself, you're independent. So when there's one solution, it's consistent and what's called independent. When there are, then you have infinite many solutions that are consistent, and since there's many, then you're dependent on everybody else, we'll say. So it's dependent. And if they're parallel and don't meet up, because they have different y-intercepts, like a y-intercept here and the y-intercept with the red line would be up here, those are called inconsistent, so they're never going to touch. Don't forget that we have things called independent and dependent. Independent is a consistent system with only exactly one solution, and dependent is when we have a system that has an infinite number. That's what we said. So I only have these two examples to go through. I have a little bit of a mix of things that are in standard form and things that are in slope-intercept form. So you need to graph it. You need to determine how many solutions there are. Then you have to kind of make an educated guess using your graph. And then you have to say, hey, is this consistent, inconsistent, dependent, independent, all of those things. So notice that the first particular problem is in standard form. So I am going to graph it using cover-up method. So I put my x and y as a 0, so I can solve for the piece that's missing. So if I put a 0 in for x, I cover it up. When does a negative y equal 2? And then I divide both sides by -1 and I get -2. If I cover up the y, it's x equals 2. Well, that's an easy one. I get 2. So what I'm going to do is I am going to graph this, and I'll try to color code it. And it's very important that when we solve by graphing and do graphs, you try to make your tick marks, your graphs, as accurate as possible. Use the lines on your paper, things like that. So I'm going to use red for the top one. So 0, -2 is here. 2, 0 is there. And then I'm going to connect them. So far I got one line. I'm now going to change to purple, and I'll put it underneath because I got some room. Put a zeros for my cover up method. I'm going to cover up the 3y. Ooh, guys, this is different. They're backwards. Don't let that catch you. So actually I'm going to put a 0 in for x. Cover it up. When does 3y equal 9? Divide both sides by 3. Y has to equal 3. Be very careful. Don't let it fool you. Now I can cover up and put a 0 in for y. Gone. So when does 2x equal 9? Divide both sides by 9, or 2, sorry. Divide both sides by 2. And so you end up with 9 over 2, and 9 divided by 2 is 4.5. So I can then go 0, 3, 1, 2, 3, and 4.5. 1, 2, 3, 4.5 is there. And if I connect those, I can see that there will be one solution. Now my one solution, I'll put it in green, for my graph is right here. And according to my graph, that'd be 1, 2, 3. It looks like 3.5, comma 1. That's where I guess is going to be. Now, that means it is one solution. It's consistent, so it's consistent, and independent. It's independent because there's one solution. Moving to the next one, as we can see, this one of the lines is in slope-intercept form, and the other one is in standard form. So I'm actually going to do this first one in pink. And if that's in pink, I can start at -3, 1, 2, 3 as my y-intercept. And this time I get to go down 2 over 1. So down 2, which will be right at the very bottom of the screen, over 1. Or I can go up 2, but then back 1. So up 2, back 1 is there. And so I get a line that looks a lot like this. Changing to the other one to do a cover-up method, put my zeros in. It's in order, so that's good. Put a 0 in. 3y equals -9. Divide by divide by 3 to get -3. That's nice. And then I can cover up the y. And then I find out that if I divide -9 by 6, I do believe I'll get a -3/2. And so, that's kind of interesting, because 0, -3 is the exact same point that I had graphed for the y-intercept there. And then I have to go to -1.5, which is -1.50. Wait a minute. These lines are the same. So they're parallel lines, but they happen to be the same line. There's an infinite solutions. It is consistent, but dependent is how you would list that. And obviously the third case, which we're not covering, are the two lines would have been parallel running next to each other. They would never touch, so therefore they would be inconsistent. And that's all you have to say then. So for our homework, the first 3, I need you to look at these equations. They're already graphed for you, the exact same way they are. You just need to determine, is the purple line and the blue line, is that considered consistent, inconsistent, independent, dependent, etc. And then 7 and 8, I need you to graph them and actually do what we just did and our work together. Have a great day.